Well, okay. Good morning, everybody. I think I'll kick off. My name's Craig Wheatley. I work for IES. I'm a director at IES, responsible for the software and its strategy and the way forward. And today, as part of World Green Building Week, I really want to address some of the important facets of the work that we've been doing recently. I want to introduce all of our partners and with the work that we've been doing with them recently as well. And really to continue the theme of our virtual building theme. IES as a company are probably best known for our virtual environment software, but it's based on a premise. The premise is that sustainable buildings require sustainability to be thought of throughout the entire design process and also throughout the operation. And our business strategy from the beginning, we're 18 years old now, believe it or not, is to create software, tools, services and partnerships to enable our users and or the client team to be able to ensure sustainability throughout the building, during operation as well as design. We see ourselves as the hub of that, and we have an approach now that we call the hub. The hub is about leveraging the use of our software for our partners. It's about being able to make the best of the sustainability of the building throughout the process, which may be software, it may be services, and it may be use of partners' information. And we'll see some of that today. Some examples of how the hub works, and I don't want to dwell on this too long for this introduction presentation, because you're going to see a lot of it today. The partners that are going to be talking today are the BRE, with Daniel Doran's at the front here. We've got Monodraft, Alex Brew. We've got Dakin with Richard Green, and we've got AECOM Davis Langdon with David Holmes. And they're all going to talk about how, between us, we've worked on projects in order to produce tools and services to improve in effect, the sustainability of the building design process. So let me tell you what's coming up. You've got a little bit more of me, I'm afraid. I'll try and keep that bit brief. This is a faculty event. And the idea of faculty is to provide you with little nuggets of information perhaps you didn't know about the software, to provide you with some training about things that are coming up, and also to introduce new things as they come along. And my part of that today is to talk a little bit about some of the interoperability work that we've been doing recently. I want to show you a few of the features for the guys that use SketchUp that you probably don't know about. There's some new things that have gone in the SketchUp plugin recently. I want to make sure you're aware of that. I want you to draw your attention to some work that we've been doing on some management tools. There's a product called IES Tap that's been newly recognised by the BRE as a tool for managing your BREEAM process. And I want to just show you the new features that come out with that. Keep that very brief. And that's the education part from me finished, and the education part about the IES software particularly for these sessions. And then I want to go on to allow the partners to speak for themselves about the work that we've been doing together. And the first one is going to be part of our work that we've done through TSB funding, the Technology Strategy Board. I don't know if you recall, a few years ago now, there was a design and decision making tools call in order to, with the government through the TSB, provided money and funding to produce tools that would help the building design and building design industry. We won a few of those. We won 3, and there's one called Optimise. And David Holmes from Davis Langdon will talk particularly about the costing element of that. So we'll show you that in a little later on. Then it's time for coffee. I'm hoping that that comes around in a nice time for you. I certainly want one. And then after then we're going to have a second session after about time for coffee to talk through a second of the design and decision making tools funded work, which is the impact project, and Daniel Doran from the BRE is going to talk through that. And that's environmental impact, I'm sure you've seen from the agenda. We're then going to get Dakin talking about their VRV plugin that's within the software, and Richard Green is kindly going to speak for us today. And then we have Monodraft, and Alex Brew is going to talk about the Monodraft wind catcher. Then we're going to get questions, and I actually would like to try and hold questions to the end of both sessions, if that's okay, so we can keep the flow of this thing going and we can keep it on time. So make a note of the things you want to ask. We are all hanging around at the end for a little while, and we'll take as many questions as you guys have got. So please save them up and ask at the end of the session. So that would be fantastic. So okay, interoperability, really important, with the UK GBC talking a lot about how important interoperability is for the design process, particularly when we're talking about BIM. We are part of the BIM workflow. We've always referred to ourselves as BPM, Building Performance Modelling, as opposed to BIM, Building Information Modelling. But in essence, it's extraordinarily similar. It's information and it's being used for a process. The BIM world is mainly to do with drawing production, but of course there's structural and other things that go with it. For us, BIM world is the performance side of things, and for the users of our software, we'll be very familiar with what those things are. I'm not going to talk to those today, but of course the interoperability between BIM and BPM is something that we take a great deal of care over, and something that is extremely important, both for ourselves as an organisation, but also for all of you guys, the users. You will be using some BIM platform of some description. It may be Revit, it may be SketchUp, it may be other platforms. Vectorworks, for instance, is one that we're going to show today a little bit. And the interoperability between that tool and your interoperability between an architect, if you're the engineer, or you as an architect, if you're using our software with our tools, is very important. We've been around 18 years. People have been sharing information and data with us for a long time. When we first kicked off, we had to create our own drawing platform because there wasn't a drawing platform to do things in 3D when we started off. We still have the drawing platform, but more and more we're doing interoperability with other building information models. So you'll be familiar with our Revit plugin. We've had that for, I think, since 2008. You'll be familiar with our SketchUp plugin. We've had that since SketchUp version 6, similar timescales. We have improved that recently. I want to show you that a little bit. Really recently, for the main release back in April, we've started to down the interoperability route using IFC. So, and particularly recently, we've been doing some work with Nemetschek and their Vectorworks tool. Nemetschek are releasing today Vectorworks 2013, and as part of that release, we have capability to take IFC from their models into the VE, and I'll show you a few examples of that and how that fits together and how it's going to work. We're part of the Open BIM Forum, or at least we're just about to be, and with the new release of Nemetschek's Vectorworks 2013, we've actually got two routes to share information. The Vectorworks 2013 has a GBXML export, which most of you should be familiar with, and we also have an IFC connection with Vectorworks as well. To give you an example of the kind of information that's already being shared, and we've worked quite hard with Nemetschek over the last 6 months or so in order to ensure this connection is robust. I'm going to show you one particular example. It's a pretty complicated building. That's not our software. That's a piece of software called Celebri, which is, if you're familiar with it, I believe it's free. It's an IFC checker tool, and this is the IFC from Vectorworks being shown in Celebri before it gets passed to IES for. It doesn't have to go via Celebri. Let me be clear about that. It's just a way of checking IFC. This model is quite a complicated multi-storey building with an interesting shaded facade. This IFC is passed through to the VE, and I'll show you a few examples of the output that we've got from it That's not terribly clear there, but the VE Gaia reports that you'll all be familiar with can work on this particular file interchange, and also all the regular sumcast macroflow type work that you can do within the software has been done with this pretty complicated model. Now, the important thing to note about IFC is it's got ways of defining geometry, which is able to cope with what we would call within IES the inner volume method, where you've got thicknesses of walls being taken into account and depths of reveals. And in IFC that's called second level space boundary. And that's a pretty sophisticated way of manipulating the entirety of the geometry through into an IFC file format for then to be used in any sustainable assessment. And if you think about if you're doing work like daylight modelling using, say, the radiance part of the software, and you're also doing energy modelling, the depths of the reveals and the thicknesses of all of the constructions that cannot come through through GBXML, for instance, that level of geometric robustness is really important if you're doing those kind of studies. Now, we're focusing particularly today, because Nemetschek are launching Vectorworks 2013 today, on their IFC interchange with us. But any of the BIM platforms that export IFC, we could now take that information into the software. And it's an alternate route. There's GBXML for you, and there's IFC from all packages. There's the Revit plugin, and of course then there's the SketchUp plugin as well. And that brings me nicely on to the features I want to talk about in the SketchUp plugin. Oh no, I forgot one thing, sorry. The sample model that you saw just there can all be got from the Nemetschek website. Since their launches today, they didn't actually have the exact address for me, so if you email sales@isv.com, I can forward that link on to you and you can get that project and you can just see how the thing fits together. It's an extremely big step for us. With the UKGBC looking to make sure that projects can be interoperable with places like Scandinavia all requiring it, with the Nordic regions all requiring it, with the GSA in America, the General Service Administration requiring that you've got interoperability. Our capability with IFC is a really important step, certainly on the building performance modelling side of things, in order to ensure that robustness of the design process between the drawing production and the analysis. SketchUp plugin has been around a long time, actually. Version 6 of SketchUp, and we're on version 8 now. And I don't know if you're on the beta trial for version 8, but our plugin already works in version 8. And there's a few new features that are going to appear because of that. There's a few features that crept in at the end of the last release that you may or may not have seen that I want to draw into it all. Why did we do it? A lot of people use SketchUp as a conceptual tool. With SketchUp aligned to our plugin within SketchUp, and also with our vWare tool, all of which are free, it opened up the capability for lots of people to get into doing energy performance modelling without actually having to worry about software upfront costs. And because in the UK our VES BEM tool is also free, in effect you can do energy performance modelling and compliance, and there's no upfront cost in software terms, which lowers that barrier when people are starting out in this world. We wanted, though, to make sure with the SketchUp plugin that it fitted the workflow of the people that were already currently using SketchUp. There was no point in creating a way of exchanging information where you had to work in a particular way that was outside of the normal way of working. Now, have we done that completely? No, because SketchUp is a tool to do things for SketchUp in a particular way, and we need information in a particular way to be able to do analysis, as most of you would be familiar. So there is some workflow, and there are some things that you need to follow, and there's a fantastic video on YouTube if you haven't already gone and looked at it. It's about an hour long, I think. Search for ISVE if you've not been on there and looked at it, and you will be taken through how this thing works from beginning to end. Not some of the new features, but the rest of it. The important thing, though, was to be able to make sure that anything, if you follow the workflow in SketchUp, can come through and can be used readily in all stages of the VE, no matter what. So let me just go and pick up on the key features. From support feedback, we know the things that a lot of folks do correctly and incorrectly, and the things that people struggle with, and the things that people don't know. So some of this you might have seen in the first version of the plugin, or maybe the second version, but we know it's not being used terribly, well, not a lot, because we don't get very many questions about it. So this particular one I wanted to highlight. There's a huge window libraries through something called components in SketchUp. Those components can be used directly within the SketchUp model, particularly if you've drawn wall thicknesses as well. You don't have to create your own window arrays. You could go to a particular manufacturer and get their components and download them into SketchUp, and you've got the thing, which is fantastic, because then you've got all of the correct geometrical information that you need in order to model this for daylighting or energy or whatever you might be doing with it later on. Not many folks are using this feature. There's a few things to note about it that's quite important. One is you have to turn on the glue feature, so it glues the component to the surface that it's on. We'll be passing this presentation around afterwards, so you can pick up on these things. When you do, we've got an accelerator in the software, which in effect, after you place the component that is a window or a door or any cookie cutter, if you like, that goes on any surface, that it automatically creates all of the reveals for you. So you place all of these windows all the way around all the stories, select them all, and say, right, cut them into the geometry. So you've in effect cookie cuttered in everything. It does that automatically for you. And the important bit in terms of modelling terms is it stores the glazed areas correctly in the VE model, ready for any further analyses. Something else folks aren't picking up on, this was in the latter version of version 2, was you only have to draw, if you're starting from scratch, the layout of the thicknesses of the walls, the floor plate, because there's an accelerator that will draw your walls, it'll cap all your ceilings, and it'll put your ceiling slab on for you. So what we see quite often, people drag the walls up, they get all the walls, they then put a slab on the top, they then extrude all that up again to create a slab. Then it's like 4 or 5 extra pieces of work you need to do, and this will do it automatically for you. It's a real time saver. If you've got a multi-story building as well, you'll notice you'll notice in a second, that there's a multiple story choice, which means that you could do 25 floors in one operation. It's a real big time saver. And this is the thing you can see, just from that floor plate, it created the enclosed volumes in exactly the way that's needed for energy modelling and daylight modelling. So it cuts out that opportunity for the odd mistake to creep in when you're doing your drawing in SketchUp. Components and groups, another new feature. We use those to define what a window array is or what a door array is. We use groups to group up buildings for simplicity of selection and deselection when you're just generally using the SketchUp program. I mean, not for reasons for analysis particularly. But there's one in there that people don't use, and it's another one of these real big time savers, and that's the whole room choice, room whole. Now, what is that? And a lot of people still ask me what that is. What it does is it actually enables you that once you have defined rooms as rooms and you've asked the SketchUp plugin to analyse all the rooms, and you'll be familiar with that, I hope, it holds that room list in memory, and it never looks at those again. It never reanalyzes them. Now, the analysis of the model sometimes, if you've got a very big model, can take a while. So after you've analysed the rooms once, you then store them as rooms. You never have to analyse them again. And if you are doing multiple variations and multiple additions and subtractions on your building, which architecturally you will be, this is a real important feature, and I know from the support questions that people aren't really using this at the moment. So please use that. That's just an example building of that. The next is identifying issues. As I said earlier on, if you follow the workflow, things work nicely, but you know, people are in a rush and you lose concentration and all those things, and sometimes errors creep in. Okay, nobody's perfect. There's a few tools in there that help you get to the bottom of where there are issues. What are the biggest issues when you're exchanging geometry or preparing geometry in SketchUp for the VE that you've not got in enclosed volume? That's the one that crops up the most. What's an enclosed volume? Simple. In this room, if we think about it very simply, there's a floor, there's a ceiling, and there's walls. And as long as you've got all of those, we know what the volume is, we know what all the surface areas are, we know all the heat transfer connections to everything that's around us. If there's some of those missing, and they're not defined as windows or as holes or as doors, we need that to be resolved. We need you to tell the software what that is. So what we do is we kind of moan at you a little bit and say, that's not a fully enclosed space. How do you know where the problems are? Well, you know if you use a SketchUp plugin, a blue space is a room, and a yellow space is a shade and obstruction or a non-complete volume. But did you know that if you select any single surface and you right-click, you can just highlight particular rooms or particular selection of rooms, or rooms that are connected to that line or that face. So if you're trying to sort through your model to establish where the issues are, it can be quite tricky in a large SketchUp model. Well, this feature here enables you to select those. The next stage beyond that is there's a highlight gaps tool. Now it'll highlight the space that isn't fully enclosed. That's been in the software for a long time now. But finding out where your particular issue is, again, SketchUp models can be quite complicated. I mean, I'm showing here a room with, you know, there's no furniture in it, there's no windows in it, there's no external landscaping, there's no people wandering around, there's no detail on this model at all. But that's not like the models that you guys are going to be using. You're going to have a lot of extra information in there, and seeing the wood from the trees can be quite difficult, and this is a real time saver. When you're trying to find that thing, that one thing that's stopping that room coming through, why might that be? You might have pushed another wall through and SketchUp's sliced that surface away, but now we've got a missing surface and we need to fill it in. And it will be simply a matter of drawing a line across the top of that gap there, and you can fill the thing in. So, very quickly they're the main key features in the SketchUp plugin, and also the newer features that are in there to help you identify some of the issues that you can get when you're exchanging geometry. Oh, and just to help you, there you go, if you hadn't seen it already. there's the gap. We'll move on really quickly because I want to allow the partners time to talk this morning. But I do want to talk a little bit about our IES Tap tool. IES Tap, Tap stands for Tracker Project. It's a management tool. It's a web-based tool. It's not part of the full VE. You can hook up to this thing anytime on the web. And what it is it's a management tool for BREEAM and Code for Sustainable Homes. What does it do? Imagine sitting in a charrette at the beginning of a BREEAM project. You're sitting with all the people around you. You are wanting to assign responsibility to all the people in the design team for the aspects of BREEAM that they are responsible for. And you want to put times against those, and you want, as the BREEAM assessor, or the person in charge on that project for the delivery of the BREEAM project, to make sure that all of those things are covered and dealt with. And what you do is, through this web tool, you assign responsibility, you assign deadlines, you assign people's emails address, practically, about who is going to do all of those things. It gives you a pre-assessment of what score you might get, and throughout the length of the project, it keeps you informed as to progress. Unfortunately, it will pester you about whether you're on time. It'll email you, I think it's a week before, then a day before, and then every day until you do your task. One of the big pieces of feedback we've got from BREEAM assessors is that there's a lot of time in keeping on top of the project and particularly on top of everybody and their responsibilities. And we thought this was an excellent way of making sure that people start to make a little bit of money out of BREEAM and not chasing the tail on it quite so much. Now we've just recently got the BREEAM badge of recognition. I don't know if you're familiar, but BREEAM now, if you want to have software for analysis or software for management or anything, you need to have a badge of recognition from the BRE to be an approved tool. We just got that, and as part of that, we've put some stuff into the software, basically to even further enhance the way that the system works. One of the issues about collating the submission requirements for the BRE is the collation of the submission requirements for the BRE. Yeah, it's a task. You have to do it, and there's a lot of work involved in that. And we spent some time with BRE Global discussing how we might be able to do that differently. And what we've done with agreement with BRE Global is you don't have to collate all of the reports anymore. You don't have to send them in via post, you don't have to put them onto a CD, you don't have to lodge them with their system. You tell BRE when your project is finished, or when a part of the project is finished, you allow BRE access to your online portal, the Tap portal, and they go in and QA check it. So there's no collation of material. All the material's already there, all stored for them, and it's all stored for the BRE in the way that the BRE have asked for it as well. So we worked very closely with them over the last few months to make sure that is as streamlined as possible. And think about the economies of scale there, not having to do all of that. And also having feedback throughout the project from the BRE if you want it. There's a real economy of scale going on there, which I think is a really important feature of this. And I had a big problem with this presentation today, and this is the big problem I had. I didn't feel it fitted with everything else we were talking about, but I thought it was a bit too important not to mention. So apologies for the slight tangent, and let's get back on track. So I'm just going to introduce the Optimise project for you, and I'll let David come along and talk about it in a second. I want to give you a bit of a background about why we did it, what it's all about in as short time as possible. The Technology Strategy Board were asking for design and decision-making tools to produce software for the industry that made design decision-making easier. Now, I might have argued back then, when this call came out, that I thought we already did do that. Well, we kind of do. But there's always ways of improving software. There's always ways of making workflow better. And we sat and thought very hard about what we wanted to do for submissions of the TSB, and we won a few projects, and this is one of them. And what is this one? The project's called Optimise, and the clue's in the name, does what it says on the tin. It's a way of having a look at multiple different options for sustainability through the software, where an optimization algorithm will help get to an answer faster than you could do yourself. So let me give you a for instance. If I had a number of orientations, a number of proportions of glazing, a number of types of material choices, a number of types of glazing choices, start to times all those things together, you soon get up to a big number of parameters and therefore simulations that you might want to study. Now let's be realistic, you're never going to do it. So what do we end up doing? We kind of think, well, we'll use our experience and we'll pick the best ones, and we'll do as much work as the fees will allow, and of course that's the right thing to do. But what if I could actually maybe extend that a little bit and create a whole list of scenarios and allow the software to go away and find an optima? Or, I chose my word carefully there, because it might not be one thing that's the optimum. There might be a few options that will work rather than a single one. Well, that sounds like a great idea. So could we do it? Well, at the time, no. Now we can. The first version is coming out quite soon. We launched it back on September the 5th. And we worked with a number of people to get there. We worked with Loughborough, who are specialists on evolutionary algorithms, and that's what we've used for the optimization. We worked with AECOM and Mott MacDonald as industrial partners for an engineering perspective. We worked with Archive, who are architects, as you know, from an architectural perspective of what we want to see from this tool. We work with SIBSI, so we got an industry-wide understanding of how the tool might work. And we work with Davis Langdon because part of optimization is about cost. Because there's no point in doing a wonderful sustainability study without a view on what the thing's going to cost. That's not the real world. And quite simply, cost in the software, in the VE software, is something that isn't really utilised in the way that it might be. And this project has allowed us to bring AECOM Davis Langdon and their data into the software. So, for that, I'll hand over to David Holmes.
So, David Holmes, I worked for Davis Langdon for 10 years now. I'm an associate, and the team now is called Business Intelligence. So it's business intelligence, our business, our intelligence, what we're doing for ourselves. And part of my role involves exploiting our own data, mainly for internal purposes, because that's where it's most important, but also more and more for external use. We produced the SPONS price books for a number of years now, lots and lots and lots of years now. I'm responsible for the A and B, which is the big red one. That's my job, but I manage the process of all the others. And part of the work over the last 3 or 4 years has been involved, okay, how can we make this movement from a book to data we can export and sell, export into our own libraries, make all that process much easier. It's always been a book issue, so it's a bit of a problem. The optimised option came along, and it's quite a good opportunity to learn how other software developers want to add our data into their software. It's not a straightforward cut and paste, it's really quite complicated. So we went back a couple of years ago, the RICS introduced the new rules of measurement for cost planning. Up until then, there hadn't been a QS rules for cost planning. We had measurement rules, but nothing for cost planning. So this was introduced a few years ago, and that drove a whole lot of other developments going on and how we organise and collect our data. For the so we're picking up all the cost estimators. So this is like stage A and B, really early stuff. We have a standard set of rules now, at last, which is quite good. The problem when it came out, obviously 2008, 2009, massive crash in the market. So it hasn't moved on as quickly as it should, but we're catching up now, I think, and others are catching up. Something like the BCIS are now converting all their cost plans, the existing cost analysis, into NRM format. So we can be some more more use, we can swap and change around. What we're trying to do with the optimised tool is establish the affordability of the building. That's what my main aim was. Okay, an architect's put this little sketch together, imported it into IES VE, what's it going to cost? Can we afford it? That's the main drive for what we're going on. And just to introduce some realistic allowances in costs, so you can see where we're all going. So RBA, we're up at AB, which is really where we need to stick. And I think if you're using the tool within the IES environment, stop there. In all honesty, don't keep reusing and trying to develop your own cost plans. Wouldn't recommend it. It becomes, you need a QS for it. There isn't like a mini QS set in here doing your work for you. You need just an awful lot of thought and effort going into it all. So but we're looking at stage A and B, all 1 and 2 on the OCCs. That's where the focus has been. Where to start? So when you import a model into the software, you can pick a building type. There's, I've no idea, a few hundred of these building sites that we look after, update every year, keep them going, and you pick the one that's closest to your building. It's as simple as that, and it'll give you a price per square metre. These are based on internal floor areas. It's quite important that when the architect draws the building, the model, he labels things properly. You know, if it's a floor, call it a floor. If it's a roof, call it a roof. You know, we have our own internal software which we use for doing our measuring. Architect recently submitted a drawing, and he used the same layout for the roof, like a C-shaped, U-shaped building, for all the kitchens. But he didn't relabel the kitchen worktops and he left it as roof. Okay, so when we did our bulk checking, because we have a bulk checker, we suddenly found we had like 3 times as much roof as we expected to have. And it took half a day to find out where that was. So labels really, really important. In the BIM world, it's critical. We have a client guide now that we put out. So when the client appoints the architect, these are the things that we want from that model, so we can import it into our model. And if it's not labelled properly, we really are stuck. We have to start again, so it's not really good. But you can quickly get quick and dirty method of measurement. Okay, my building is going to cost about £1,500 a square metre. Import it in. IES tells you how big it is. Do the multiplication. That's obviously going to cost me to do. So straight away you've got, okay, I'm a £20 million building, I'm a £25 million building. I'm getting some order of costs very, very quickly. You see there's a range. It doesn't mean you can't get it for less or for more, in all honesty. It's just that's what we think the range should be for a particular building type. Lots and lots and lots of things affect the price of buildings. We can't just give you a price for a building off the shelf. It doesn't work like that, I'm afraid. Really nice, but it doesn't work like that. Next level down, once you're satisfied that your model's working, is to say, okay, let's do a bit of an elemental breakdown on what's going on my building now. Okay, so again, there are models set up, templates set up within IES. Not too many at the moment, but that's going to increase over a short period, just to allow you to get some breakdown of where the money's been spent. £25 million for a building, fine, but how much is my cladding costing me? How much is my roof costing me? What sort of options have I got in there to adjust the price for those things? And that's what this gives you. And if you click on the cost plan tool, create a cost plan, based on it, pick a template, and it will fill it in for you. Then it multiply by the floor area, give you the rates. So all those rates down there are for the gross internal floor area. You need to be aware, two things. We don't include demolitions, remedials, all those sorts of bits aren't there because they really are project specific, just can't do that one. And we tend not to include external works. So again, they're too project specific. So we just get the core building, walls and roof, substructures, and away you go. So that's not the answer, but you're going towards the answer. What else do I need to think about? BSIS do the same format, so if you subscribe to the BSIS, you can get their cost analysis, and they do exactly the same thing. I think they just have like 16,000 building types instead of 400 or 500. Same answers, anyway. So you can use that as well, just type numbers in. Not there, just sit and type numbers in, but you don't want to do that really. Just go for it. So think about these two, what's missing, what's not in there, sorry, what's not included is more important in all honesty. You need to think about what have I not got? And do some risks assessments. There's lots of things that affect the price of the building, and we can't list them all down, there's just too many. You need a QS to do that for you. And we need to keep our earning our fees, I'm afraid, so that's what we do. So looking at a cost plan, this is from Cost Plan Pro, which is this is what the new cost plan's called. There's my main elements, substructure, superstructure, internal finishes, and click on superstructure, and I get a bit of breakdown. There's my upper floors, roof, those bits and pieces that guide me to where I'm going. There's a little code, which I don't see, there's a code number 11, which in IES speak is gross internal floor area. So that's a straightforward multiplication. And it just gives you a bit more analysis. What you can then do is click on Windows external doors, and that will expand a little bit more, and you can type in your particular window types if you want, or you can select an area of window. Different number. So 11 is GIFA, windows are 32. Pick code 32, and the software tells you you've got 150 square metres of windows. What you then need to do is say, okay, that window is going to cost me some money. It's not a GIFA, it's not a £50 a square metre, it's £50 for my window rather than £50 for my floor area. And you pick hardwood, softwood, steel, aluminium's around, and a few different types. Not lots and lots and lots and lots, but there's enough to make it work for you. And you say, okay, I want this one. The double glazed, a reasonably sized building, built reasonably sized window, it's going to be 190, 240 pounds a square metre for that window, which will be a fixed window. All right, it's up to you. It's your cost plan at the moment. Go and change it. You can change back to the default if you want to. There's a way to do that, but just go and change it. Gives you the cost plan. And you can work your way through all the elements if you want, if you really, really want. Wouldn't recommend it. that you need to stop, I think, at elemental type level, because that's where all the that's where the benefits are, because you can quickly run through those and do some options very quickly. And again, be aware of what's not included. Because the way we work our price out, we lump all sorts of things together and say, okay, a door costs this much money. If you're in a price to pick for a door from a price list, actually it does include all the things I'm going to need to make that door work. Lintel, frame, grave, all those bits and pieces tend to get measured separately. So don't sort of lump things together too much, but think about what might be there. And that's it. That's how it works. You click on the button. I'll have one of those. It's a 32 on my window area, and away you go. The other thing that we built in, you need to make adjustments to these things. Location is quite important. So there's a whole series of locations available for you to pick from. Our prices tend to be like 1. So we assume we've got a price of location equals 1, and we'll work from there. So inner London, you're going up sort of 10% or so. Birmingham, perhaps down 3 or 4%. So think about those sort of adjustments that you need to make the cost plan work. Where is it going? Think about the timing. I'm pricing it today, but it's not going to be built for 2 years. So there's an index formula that allows you to predict what's going to be going on in 2 years' time. We produce quarterly updates. We have our own tender indices. And so prices today, if you bought this tool today with the prices today, the TPI is 466. In 2 years, it's probably going to be a bit lower, in all honesty, but it's going to be about 470. So you click on, okay, on my target TBI, as a date pops up in June 2014, what's it going to be? And it will just add on some money for you. And you can see all that when you go back to the cost plan tool. It will show you base price, index price. So you can see what's going on all the time. We like to see where we came from as well as where we're going to. So it's all there to be grabbed. A scaling factor, how complex is your building, and a quality. Quality is easy. It's a high spec, low spec, means what it might be. Complexity is much more difficult to sort out. Different things drive costs. So the shape of the building is really, really important to us. The water floor area is really important. The net to gross efficiencies are really important. So think about how complex your building might be. It just moves you up or down the scale. Currency is just UK at the moment, but one day, you never know. And back her up. So every quarter, the indices get updated, so that will be updated just via download if you've got the software. And this is what we do. It's just a January, February, March. Those are the years. This is where we think we're going. Invariably, we probably go, I think it's 2013, and we probably got to 2015. Usually I try to sort of predict about 3 years away. At the moment, it's a bit flat, so it's not really exciting. But one day, start going up again, and we can start building properly. So that's how all that works. But all you do, you just pick a date. It's easy. You need to have some idea. You need to think about it. Cut this terrible slide, but this is desirable is for costs. Okay, nothing to do with design, features, engineering, nothing at all. The cost is important to us. Little boxes are really, really efficient. Look at water floor areas, water floor plans, water floor ratios, really important. And the net internal areas. The developer, net internal area drives the development. So if you haven't got a decent gross to net ratio, it's going to put the cost up. It's going to put his cost up. So think about how complicated your building is. We try to work out ways for the IES software to decide for itself how complicated, but that's quite complicated in itself. There's not an answer. There's different options, different ways of looking at things. It depends what you're doing and where you're in the process. So as QSs, we take all this on board when we put it together. But trying to write that into a little program is really, really difficult. Think about the size, think about the complexity. Specification comes in here as well. City centre, London, tower block, completely different specification to one in Birmingham. Massive difference in things that's going on. It's really important. And think about the programme and procurement. You know, if you want this a building in half time it normally takes, it's going to affect everything. It can affect your cost. Procurement is really important. It can affect probably 5-6% of the cost just because you procure it in a different way. So we try to we do procurement options and recommendations, all those sort of things to drive the cost down. And probably the most important at the moment is the market. What's going on in the world? Where's it going to be? And again, at the moment, it's really easy because it's flat. Flat going down, probably outside London. So it's really terrible. So what's the state of the market? What's happening? You know, we're not going to be flat forever. One day, next year, it's going to start going up again. That will get reflected in our TPIs when we do every quarter. So you need to make sure those are subscribed, those updates are being done for you. But think about that one. There'll also be a bit of commentary about what we think is going on currently in the market. So I think the hot thing at the moment is steel, probably coming down. Think about those things, really important. And the little QS inside the IES software doesn't think about those. All right. So this is just a sample of some water-flow ratios, which are a massive driver for tower blocks. So 3 different scenarios. Water flow 4, 5, 6, 9, 6, 6. Ideally 4, 5 or 4 is where we want to be. Learn the better. Brilliant. Thank you, Mr. Deed. But it's not always the case, so you need to work your way up. So think about how tall the roofs are, and how, your floor-to-floor ceilings, your floor plates, the shape of the building, all affect the water floor, and that's what it does for a typical London office block. So it makes a massive difference. Not a very big climb, 10%. You've got 0.45 to 0.6 in terms of water floor ratio, which isn't ridiculous. A 0.6 isn't too bad, but it's adding 10% to the building price, just because of the shape it is. So if you're drawing odd shapes with lots of angles and cutbacks and reveals, it's going to increase the cost of building. It's quite a steep curve. It's not so important on residential, where it goes flat. Residential towers, it is more important. So all these things affect how we're going to put these things together. But hopefully, if you run through all these things, and all the right boxes, and you've given it a bit more thought than you would do, you're going to end up with a cost plan. The costs within IES, the software, they come from SPONs. So this is what SPONs is based on a project value of around, it's moved, it should be about £3.5 million is where we think, okay, that's a typical value. So up to 5, perhaps down to 2.5 million, the rate should be okay. It's not making much of a difference. Once you get beyond those, that's you start thinking about it again. You know, I need to think about, if it's a massive, massive project, I need to think about reducing my cost a little bit. How do I do that one? If it's a very small project, don't use the software, basically. It just doesn't work. It's just too unique, but it just dives off. So a project in that range, fine, we can make it work. And it does work. You know, I've done a lot of analysis on these things over the years, so we know where we're going. There is a diminishing returns. Once you get to a certain size project, it doesn't save you any more money. So you've got to think about those sort of things. But a very small project can keep costing more and more and more money. And it's ideally, it's all for new build. We don't do refurbishments are really hard for us to do, so probably much more difficult for anything else to be done. So it's all new build. And there are a series of templates. We have offices, schools, hospitals, so like business parks, like low offices, those sort of things. They're in the system now, and over the next sort of month or two, we're going to add a few more of those. So we try to expand the range of offices, so we get a different feel. But if you pick the one that fits closest to you, and you should be able to sort of some confidence, I think, say, okay, this building is going to cost me £25 million. Then when you go to the QS, and he says, ooh, like that, it's more than that, my boy. Say, no. Right, this is what we think should be going. This is what should we do. Let them justify it. And if they do say, if we come to Davis Landing and we say it's £30 million, just say why. Ask us to explain why. There'll be reasons, but just understand what those reasons are. That will help you in your feedback to the next project you do, what's going on in here. If you do all of these things properly and carefully, you end up with a cost plan, which you can dump out to Excel and still play around with. You can label it and brand it or whatever you want to do. This is quite a simple spreadsheet, really, as to where we end up with. Gives you, if you made any adjustments on the codes, you can see where those are. But you need to be careful when you do that to make sure you pick everything up that goes into it. Like on windows and external doors, if you move from code 11 and just say I want to area windows, don't forget the doors. Don't forget the other things that might be in there as well. You've got to include all those things in. It won't do it for you. It's really, really not that clever. But it does work. And I've done a few tests myself using models from AECOM, because I pinched their models. And we're close enough. I think it works for probably within plus or minus 5%. We can get this down to. Okay, but you have to understand what's happening and make lots of different allowances yourselves. Yeah, everything isn't there. The building's there, and I think we're reasonably confident we can get that sorted out. But once you get outside that, then no, you need to have these things in. I think that's about it, really. It's really quite a simple tool to use. Much simpler than the IES software for me, I'm afraid. There we go. And it does work. It's a spreadsheet. So if you're comfortable with spreadsheets, you're comfortable with this. You need to learn the codes for the different area measurements. That's quite important. And you need to label your drawings carefully. You need to tip your constructions carefully. There are a set of constructions for the Optimize tool, which looks at, I think we've just got light, medium, heavy wall constructions, so you can pick what you want to do. That's not really enough, I think, for a QS would want to sit in. But early days, that's probably all you want to know. Is it going to affect the price of my building? And am I adding money or am I saving money? At the end of the day, that's all you can need to do. I made a design somewhere, a design change somewhere, it's cost me more money. I made a design change somewhere else, it's saved me some money. So that's where we're trying to get to. And then, you ring up Davis Langdon, and we come and sort that out. But that's where we are now. Okay, thank you.
David spoke at length about the cost plan tool. Cost plan's been in the software for a long time. It's now Cost Plan Pro. It has the SPONS data within it. David mentioned it'll be a quarterly subscription that you can sign up to. That'll mean you get SPONS data every quarter updated as time goes on that lives with this program. You don't have to, David won't like me saying this, but you don't have to have Davis Langdon data and all the SPONS data. And you can do it yourself and keep it updated yourself. But there's an economy of scale of having that data coming to you automatically, of course. Though, as you can see, and maybe not so many of you are familiar with the cost tool, there's quite a bit to it. And of course there'll be the usual web training sessions and the usual videos being collated for you all to take advantage of. And of course there'll be face-to-face training and all those things too. The Optimize tool in itself is made up of a number of different pieces. And the cost plan bit that David showed today is one piece of it. The optimizer itself was what we launched at the event on the 5th of September. And we should give David a bit of a round of applause, I think. Thank you, David.